Hello everyone and very good evening. Welcome to Resultant AJ YouTube channel. I'm Vikas Sir. I welcome you all to this very important session. I hope all of you are doing fine and your preparation for RRB JE 2024 is going well. So there was some technical issue, I guess, in the YouTube because of which I was not able to start the session at 8 p.m. But I think now it is fine. That's why the session has started. And so good evening, everyone. I guess most of you were waiting for the sessions, for the start of the session. So my dear students, I'm back again on your Resultant YouTube channel, where you know that at 8 p.m. we provide you mechanical YouTube classes for mechanical engineering. Today we are going to provide you 300 plus most expected question part 2. So as you know that in the previous session we have solved the most expected questions for either you are preparing for RRB JE 2024, CBT2 or SSC JE CBT2. For both these examination, you can come to this platform and you can prepare with us at 8 p.m. At 8 p.m. the mechanical classes will be provided to you. Okay. I am taking here mixed questions. Mixed question will be from the subjects of thermodynamics, applied thermodynamics and fluid mechanics. So let's begin the session. Those who have joined me for this session, please take out few seconds to like and share the session as well. So let's quickly start the session. My dear students, as you know that it's very important for us to subscribe the channel because our YouTube channel, if you find, it's very new and the number of subscribers are also less. So it's my request to everyone, those who have joined me for this session, if you have not yet subscribed the channel, then please do subscribe it and also press the bell icon which is just near to the subscribe button. Hello MS, good evening, welcome to the session. Also, if you have not liked the session and shared the session, please do that because we want more and more students to get informed about these classes that are being conducted on Resultant AJ YouTube channel. Okay, so good evening everyone. Once again, this is my short description about myself. I'm Vikas Sir, having more than 7+ years of teaching experience. I have taught more than 1 lakh students for different competitive exams like GATE, engineering services and different A and J exams. Also, these are my subjects. If you want to study for these particular subjects, if you want to enrich your concept for these subjects, you can definitely continue and watch my classes. Okay, and at 8 p.m. not only these subjects, other subjects will also be covered. Like Dheeraj Sardana sir will be taking the subjects of production very soon. He will be starting taking the classes. Okay, and Suraj Gopi sir will take rest of the subjects. Okay, so all the subjects will be covered at 8 p.m. for mechanical engineering. Also, my dear students, I want to inform you that if you want to prepare for RRB JE CBT2, particularly for CBT2, you can join our AIM batch. Okay, and if you want to prepare for both CBT1 and CBT2 of RRB JE 2024, then you can take mission batch. Okay, one more information, as you understand that it's very important, you can see in the chat box. One more information for you guys is that sometimes you guys feel that when you want to purchase a course, the price of the course, although it's not too much, for some of the students you cannot afford these courses, right, because of the price. So we are providing you a scholarship test that will be conducted on 7th and 8th of September. Okay, and you can give this scholarship test on our Resultant app. Okay, you can download our Resultant app and give the scholarship test at any time on 7th and 8th September. If you perform well in this scholarship test, okay, you get good marks, then you will get discount on our courses. That is, you will get discount on our paid courses, these paid courses. Okay, that is a very important information. So please share this information to all your friends also, that on 7th and 8th September they can give the scholarship test and they can get discount on our courses. Okay, so let's solve the questions quickly. Yes everyone. MS, good evening. So the other mechanical class timing. So there are no other mechanical class timing. There is one mechanical class, and the timing of the mechanical class I have already told you. Okay, just a second. I think I was about to tell you one more information. Yeah, there is also one. If you see the description of this session, if you see the description of this particular session, you will find a form which is given, and that form basically you have to fill if you want a guidance for RRB JE 2024. If you want us to conduct a session for you, or if you want to get guided by the mentors like me or other faculties, that how you can prepare for RRB JE 2024, then there is a description box. There is a description in the, if you see the description of this YouTube channel, okay, this YouTube class, you will find that a form is given, a Google form is given. You can fill this form, your details will be there, and based on that, if you are having any query regarding RRB JE 2024, then we will definitely help you for that. Okay, so let's begin the session. Question number 1. And as soon as I showed you this, okay, already filled syllabus for test, already filled. You want syllabus for test. Okay, Subhadeep, maybe today I don't know the syllabus, but tomorrow I will definitely tell you the syllabus. Okay, I will ask my team what is the syllabus of this scholarship test, and I will inform you in advance about it. Okay, the right answer for this question is correct statement for isothermal process compared to adiabatic process. So you know that isothermal process is a process. You are comparing isothermal process with respect to adiabatic. In isothermal process, your temperature will remain constant, while in the adiabatic process, there will be no heat transfer. It is often carried out in a closed insulated container. No, isothermal process does not require an insulated container, so this is wrong. No change in the heat between system surrounding. No. The meaning of this statement is that in isothermal process there is no heat transfer. That is also wrong. In isothermal process, change in heat is 0. That is also wrong. Increase or decrease of internal energy does not occur. Yes, because internal energy remains constant for constant temperature process as compared to adiabatic. So the right answer will be option D. Very good. Hello Pushpin, good evening. A system has 4 kg of the fluid having CV is equal to 0.8 and that expands in a frictionless piston from initial state of 1 megapascal 200 degrees Celsius to 1 megapascal 100 degrees Celsius. What is the net work if there is no heat transfer? In this particular question, it is being asked that how to find the net work. Okay, how to find the net work if there is no heat transfer, if the heat transfer is 0. Any way how you can find it? So if you apply the first law of thermodynamics, Q minus W is equal to du. If the heat transfer they are mentioning there is no heat transfer, then the work will be equal to minus of du, or it is equal to minus of mCv dt. Now what is dt? Change in temperature, that is you can write it as mCv T1 minus T2. Everything is given here. Mass is given 4, Cv is 0.8, T1 is equal to 200, T2 is equal to minus 100, that is 100 into 8. So if you solve this, you will get the right answer. 4 into 0.8 into 100. Okay. So you will get 320. Answer should come 320, but the option is not given. I think the right option is not given here, right? The net work has to be around 320, right? 4 into 0.8, 8 4 30. Yeah, 320 should be there. 320 is not the option. Okay, so let's make it as 2. Make it as 2 kg. Okay, I think there is some problem with the data. If you make it as 2 kg of the fluid, you will get the right answer. Just make it as 2 kg rather than 4 kg. So if you multiply with 2, you will get 160. The 160 will be the right answer. Okay, but the question is, should we put the right sign, because work will be equal to minus of du. It will be minus of du. So minus of du will be equal to 160, right? But they are asking the sign. So if you have to consider sign, so you have to put minus 160. Okay, so the right answer will be option A. Are you getting this? Why we have to keep a minus sign here? Because what we have done for the calculation, we have just multiplied with the minus sign here, but here sign is required. You have to keep the sign. So if you have to keep the sign, then what you have to do here is, just a second, you have to keep the sign here. They also need the sign. Okay, so minus mCv dt. Now put all the values. Minus 2 into 0.8 into dt is T2 minus T1. Now if you solve it, you will get minus 160. Okay, Next question. In a Brayton cycle, the air enters the compressor at 300 Kelvin and maximum temperature of the cycle is 1200 Kelvin. Alright. What will the thermal efficiency of the cycle for maximum work output? For maximum work output, if you want the work output to be maximum in the Brayton cycle, the efficiency will be 1 minus square root of minimum temperature by maximum temperature. This is the formula. Okay, so just put the values. 1 minus square root of minimum temperature is 300, maximum temperature is 1200. If you solve this, you will get 50% as the answer. Okay, 1 minus 1 by 2, that is 50%. Okay, right answer will be 50%, option C. Very good. Next question. A refrigerating machine works on the reverse Carnot, and there is also one concept in the Brayton cycle. There is one more concept in the Brayton cycle, that efficiency of the Brayton cycle for maximum, when the net output becomes 0, and the efficiency is called as maximum efficiency. So that maximum efficiency is equal to 1 minus minimum temperature by maximum temperature. But when you get this maximum efficiency in the Brayton cycle, at that point net work becomes 0. So if you find the maximum efficiency, it will come out to be 1 minus 300 by 1200. Okay, so 75%. 75% will be maximum efficiency and 50% will be the optimum efficiency. Alright. A refrigerating machine working on reverse Carnot refrigeration cycle consumes 7 kilowatt of work and produces refrigeration capacity of 1260 kilojoule per minute. For maintaining the refrigeration temperature of 240 Kelvin, what will be the temperature of heat rejection of the cycle? So how are you going to solve this question? Tell me. Just a second. How are you going to solve this question? First of all, it is reverse Carnot cycle. So COP will be equal to refrigeration capacity to the power input or work input. Okay, but here the refrigeration capacity is given in kilojoule per minute, so you have to convert that into kilowatt divided by 60 and 7. Solve this. So you will get 3. COP will be 3, and now COP is equal to what? It is equal to 3, that is equal to, because it is a refrigeration machine, it will be lower temperature divided by higher minus lower temperature. Just put all the values. To maintain 240 Kelvin lower temperature, what is the temperature of heat reaction? Okay, so 3 will be equal to 240 divided by higher temperature minus 240. You can also select from the options, you will get the right answer. What will be the right answer? Tell me everyone. Option D, 320. Very good. So if you put 320 here, you will get 320 minus 240. Okay, and if you solve it, you will get COP3. So the right answer is option D. A stationary mass of a gas is compressed without friction from initial state of 0.2 meter cube and 0.1 megapascal to a final state of 0.1 meter cube and 0.1 megapascal. The pressure remaining constant during the process. There is a transfer of 35 kilojoule of the heat from the gas during the process. The internal energy of the gas change will be. In this question, it is being given that the pressure is remaining constant, the internal energy you have to determine. So, hello Kuldeep, good evening, how are you? Work for constant pressure process is equal to pressure into change in volume. I know that many of the students come in the class, some of the students are preparing full time for any exam, but as you know that some of the students who are preparing for a very long time, you must be also doing some private job also, maybe some private job, and also preparing simultaneously for some competitive exam, government exam. So it's good that, like Kuldeep, I know is I think in some private job, and maybe some of you also, because you have to also support your family and you have to meet your expenses, while you have also big dream of getting selected in some government exam. So both of the things are being managed by you guys. That's very great. Okay, not all the students can do that. Those who are able to do that, it's very great. Great respect, guys. Great respect. There is a transfer of 35 kJ because even if I at this age, if I want to prepare for something along with job or anything, it's very difficult. I can understand. So I can understand your pain. I can understand if you want to do something while you are in a job, it's difficult. But it's great respect if you guys are doing that, because if you have a great vision, you can definitely achieve it. Minus 35 plus 20 will get how much? 15. That is minus 15. The right answer is option A. Clear? Are you all getting this value? Yeah, have I done some mistake? This is a heat transfer from the gas. If the heat is getting transferred from the gas, it is heat rejected. So it is heat rejected, my friend. This is heat rejected. And it is heat rejected, so there will be a minus sign. So minus sign will be there. Now work is coming out to be minus, negative. So if the work is minus, so this will be minus sign put over here, minus minus plus. So this will be minus 15. Are you getting minus 15? Oh, sorry, my bad. Mistake. I've done some mistake in the work. This will be minus 10. Why I am finding minus 20? Writing minus 20 here. This will be minus 10. So this will be minus 25. Sorry. I'm sorry. हम लोगों को कब मिलेगा जॉब? मिलेगा आप लोगों को जॉब. You will definitely get the job. And see, आप लोग बस मेहनत करते रहिए. You guys, whatever you guys are doing, you guys are doing great. I know that many of you will be around 30 also, right? Close to 30 or maybe 28, 29. So your upper age is also crossing. Maximum age is also, many of you may have crossed your maximum age of applying for the exam or filling your form. It's good that RRB JE has given us an opportunity. Even I could have also applied for RRB JE, but I can understand I can't do that. Okay. But you guys are already in a practice, in a process of practicing or process of studying, and you know all the subjects. Only thing is that you need to just revise all the subjects once, and you have to give some time for non-tech. You can definitely clear the exam, right? But I cannot do that, so that's why I have not filled the RRB JE form. Earlier I was thinking that the maximum age is 36 and I can definitely apply for it, but even most of my technical subjects are not prepared, like SOM, TOM, industrial, many other subjects. So except thermal FM, what I know, nothing. So that's why I have not filled the form. But you guys can do it. Okay, you guys can definitely do it because you are preparing for a long time. You have all the subjects ready. Just focus on non-technical. You can clear the exam. In vapor compression plant, the refrigerant leaves the compressor and evaporator with the enthalpy of 205 and 177. Enthalpy of leaving the condenser is also given. If the mass flow rate of the refrigerant is 0.2, what is the refrigeration effect? Now, refrigerant effect means it's actually refrigeration effect. Now, refrigeration effect is being asked in kilowatt. First of all, what is refrigeration effect? Refrigeration effect in kilowatt is equal to mass flow rate into H1 minus H4. What is H1, H4? There are three enthalpies given here. I told you a technique of how to understand which enthalpy is highest. So H2 is greater than H1 and H1 is greater than H3 is equal to H4. Remember? So highest enthalpy is 205, that will be H2. Then 177 will be H1 and lowest is 105. Okay. Just put all the values here. You can understand that this is H1, this is H4. So mass flow rate is also already given 0.2 and H1 is 177 minus 105. If you solve this, you will get directly the value in kilowatt. Are you getting this, everyone? Simple concept. So if you want to get to know that which enthalpy value is there, just remember this order. Okay. If you remember this order, you will not find any problem. Clear to everyone? Just a second, just a second. Yeah, just a second. Maximum, likewise, if they ask you in the exam, what is the power input? Then power input will be mass flow rate into H2 minus H1. So you can also find the power input. It will be mass flow rate, which is 0.2 into H2, which is H2, 205. The highest enthalpy is H2. The middle one is H1 and the lowest is H3 is equal to H4. You can get the power also and you can find the refrigeration effect. If they ask you COP, you can just divide this 14.4 and power by power, you will get COP also. Maximum possible COP of a solar absorption system with generator temperature of 360. If there will be a numerical from vapor absorption, if there is any chance of having a numerical from vapor absorption refrigeration system, that can be from the COP. And how to find the COP? It's also a very simple technique. There are three temperatures here: generator temperature, surrounding temperature and evaporator temperature. Just write these three temperatures in this order. The highest temperature, which is 360, is the generator temperature. The middle one is the surrounding and the lowest temperature is evaporator temperature. Now, after you have written all this temperature in this order, what you need to do here is just do one thing. Between these two temperatures, apply the formula for efficiency of the heat engine. Between these two, apply the formula for COP of refrigerator. And just multiply them, you will get the COP. So, efficiency of the heat engine will be 1 minus 300 by 360. COP of the refrigerator will be 270 by 300 minus 270. Just multiply these two, you will get the answer. COP of vapor absorption you will get from. Okay. Efficiency of the heat engine into COP of refrigerator. Okay. Just put the values, you will get the answer. So if you solve it, you will get the right answer. What will be the right answer? 1 by 6 into 9. Okay, so you will get 1.5. Okay, right answer is option D. Clear? So this is a simple concept on which you can solve these two numerical. Remember this. Whenever you have to solve a numerical of vapor absorption, write these enthalpies in this order. Either you have to find refrigeration effect, or you have to find the power input, or you have to find the COP. If you want to write COP, you can write H1 minus H4 by H2 minus H1. You can find the COP directly. Okay. So this is a technique you remember for vapor compression, and this is a technique you remember for vapor absorption. Clear? In Hagen-Poiseuille's flow of viscous fluid, one of the following pair of forces are balanced. Hagen-Poiseuille flow, you know that it is a flow of, or we can say laminar flow of fluid through horizontal pipe, that is your horizontal pipe. That is your Hagen-Poiseuille flow. In the Hagen-Poiseuille flow, which forces are matched? The forces that we match are pressure and viscous force. So basically we match these two forces. And we also study in Hagen-Poiseuille equation. What is Hagen-Poiseuille equation? Hagen-Poiseuille's equation is P1 minus P2 by rho G, which is equal to 32 mu VL by rho G D square. Okay, so you get this kind of equation. The line of action of the buoyant force acts through the centroid of. What is the buoyant force? The force which is experienced by a fluid. Let's say we are having some, okay, let's say we are having a body which is at rest, okay, and it is submerged in a fluid. So this is a fluid and this is some body which is submerged in the fluid. So what will happen? If you submerge this body in the fluid, what will happen? This body will experience a force which is acting in the upward direction at some particular point. The point where this force acts, that point is called as center of buoyancy. That is called as center of buoyancy. This is the point where the buoyant force will act, and it is also called as, center of buoyancy is also called as centroid of displaced volume of the fluid. It is also known as centroid of displaced volume of the fluid, center of buoyancy. Which device is popularly used for measuring difference of low pressure? If you have to measure difference of low pressure, then which device we use? Okay, yeah, I forgot, Gautam. Yes, I have to make this question bold, more bold. Are they not clear to you? But I don't understand. This is a black background, white layout. All the texts are completely cleared. I think even if I see in the mobile phone, I can see everything is very clear. Do you want me to bold this question or whatever I am writing? The text that I am writing. Which device is used for measuring difference of low pressure? So for that we use inverted U-tube differential manometer. Why inverted U-tube manometers? Like like underground pipelines. Like in the case of underground pipelines which are placed underground, okay, if you have to find the difference of the pressure, then we use inverted U-tube differential manometer. Okay, but there is one thing about the inverted U-tube manometer, that the density of the fluid in the manometer is less than the density of the fluid in the pipe. Okay, if we have to use an inverted manometer, if you really want to make the proper use of the inverted manometer, then the manometric fluid should have low density than the fluid in the pipe. Okay, questions? All right, no problem. Okay, I will see, these are all, when I make these questions for your class, I don't think I will actually forget that I have to make each and every question bold. So it will individually take a lot of time to select all the question, then click the bold, but I will remember it. Okay, somehow I forget, because I think you came in the class after a very long time. Maybe after 3 to 4 days you came in the class, right? So maybe I have forgotten that. In the inverted U-tube differential manometer, how is the specific gravity of the manometric fluid used relative to the fluid flowing the pipe? I think I have already told the answer for this question in this page, that the specific gravity of the manometric fluid should be, in the manometer, should be less than the specific gravity of the fluid in the pipe, right? So the right answer is option B. Already discussed with that. I've already told that in the previous question. For a fully developed pipe flow, how does the pressure vary with the length of the pipe? How does pressure vary with the length of the pipe? So let's say they are talking about fully developed laminar flow. For fully developed laminar flow in the pipe, the pressure difference between two sections, let's say these are the two sections, okay, and the length is L. The pressure difference is P1 minus P2 by P1 minus P2 is equal to 32 mu VL by D square, somewhat like this. So it is, the pressure difference is directly proportional to length. So linearly, it varies linearly with the pressure. Okay, the length is directly varies linearly with the pressure. So the right answer is option A, not parabolic, not exponential, not constant. It's linear relation. Water flows between two plates of which upper plate is stationary. Water is flowing between two plates. Upper plate is stationary, okay, and the lower one is moving with the velocity of v. Okay, if this is stationary, its velocity will be u0. Okay, what will be the velocity of the fluid in contact with the upper plate? So let's say there is some fluid here. The fluid which is in contact with the upper plate will be having what velocity? So you have studied about the no slip condition. As per the no slip condition, the fluid which is in contact with the plate, upper plate, which is stationary, will be having the same velocity of the plate. So that will be zero velocity, okay, because of the no slip condition. Clear? The velocity of the fluid will be actually zero, which is in contact with the stationary plate. The relation between the shear stress and velocity gradient of the fluid is given by. Shear stress is given by, here they have Z represents shear stress and A is some parameter, okay, du by dy power n plus p. So this is some equation that is given for a fluid. All right. Which of the following condition will hold for a Bingham plastic fluid? You know what is Bingham plastic fluid? Also known as ideal plastic fluid. Also known as ideal plastic fluid. So, like example is toothpaste. Toothpaste or any kind of, you must have seen any kind of tube. Have you seen any kind of tube, like it is kind of a cream, any kind of, any kind of cream that you apply for getting, more beauty, or sunscreen, any kind of cream. If you just press from the back, it will just, the process of extrusion will take place, right? So toothpaste is an example of Bingham plastic fluid. So what kind of behavior it shows? This is a behavior that is shown by a Bingham plastic fluid. Okay. So for Bingham plastic fluid, what will happen? So n will be equal to 1, n will be equal to 1, and this b will be equal to 0. B will be equal to 0. A will not be equal to 0. What is B? This B will be equal to 0. Just a second. No, B will not be 0. What I am saying. Maybe I have gone crazy. There will be some value of the B. There will be some value of B. This is called yield stress. Yield stress. Some yield stress is required, which is equal to B, and this A will be the viscosity. Okay. So A and B will not be equal to 0, but N will be equal to 1. This is the relation of Bingham plastic fluid. Okay. Bingham plastic fluid. Clear to everyone? If this is a this is the right answer for this question. A liquid flows with the same velocity through the two pipes 1 and 2, having the same diameter. If the length of the second pipe be twice that of first pipe, that is, length of the second pipe is equal to 2 times the length of the first pipe, what should be the ratio of the head loss in the two pipe? What is the relation of the head loss? Head loss is equal to having the same diameter. It is equal to either FLV square by 2GD, you can write, or you can also write head loss as FLQ square by 12D power 5. Which relation will be used here? A liquid flow with same velocity through the two pipes having same diameter. Velocity same, diameter is same. What will be the relation between the length? So we will not be using this relation, we will be using this relation because they have given the relation between the velocity and the diameter. Okay, so this relation will be used here. Head loss in the two pipe, head loss in the first pipe to head loss in the second pipe will be equal to L1 by L2. So this will be L1 by L2 will be equal to what? It is 1 by 2. This will be 1 by 2. So right answer will be option A. Okay, clear to everyone? Why we are not using this relation? This is also one relation of the head loss, but this relation would have been used if they have talked about discharge, but they have not given anything about the discharge and diameter. If the relation would have been, if something would have been given about the diameter and discharge, okay, then we would have used this relation, but they are talking about the velocity and diameter, so we'll be using this relation. Okay, with respect to this relation, you can say HF, that is head loss due to friction, and L, length, is directly related. Okay. The temperature at which pure water transforms into water vapor at constant pressure is called as. What is this temperature? At which pure water transforms into water vapor at constant pressure. That temperature is known as, yes, we have a pure water getting transformed into water vapor. The pure water is getting transformed into water vapor. That temperature will be called as saturation temperature. That is, a phase change is taking place at constant pressure, and also temperature will be constant. So that will be called as saturation temperature. Okay. A nozzle expands air from 8 bar and 540 Kelvin to 5.8 bar and 495 Kelvin. Find the velocity of the air at exit if specific heat at constant pressure is 1.005. Velocity at the exit of the nozzle, you know the formula, it is square root of 2000 into enthalpy at the inlet minus exit. Now, since enthalpy difference is equal to square root of 2000 into Cp of T1 minus T2, you can use this relation. Here T1 and T2 both are given, Cp is also given, everything is given, just put the values, you will get square root of 2000 into 1.05 into 540 minus 495. Okay, solve it and tell me the answer. Sorry. Okay, so I want to tell you two things, guys, that on this Saturday and Sunday, that is 7th and 8th, we are providing you a scholarship test that you can do, that you can attempt anytime on Saturday, Sunday. And if you perform good in the scholarship test, you can get discount on our courses for RRB JE. Okay, so you can attempt that scholarship test on Saturday, Sunday. Tomorrow I will also tell you the syllabus, what will come in the scholarship test. One more thing, that if you want to get some guidance regarding RRB JE exam, then in this description of this video there is a Google form. You can fill this form, and if you are having any query regarding RRB JE, will help you. Okay. Which of the following is false for entropy? False statement regarding entropy. Here the right answer will come out approximately 300 meter per second, not exactly but approximately. You can use the calculator. If you are getting 300.74, approximately 300, that is fine. Okay, use calculator. There is no problem in using calculator, because if you are preparing for RRB JE CBT2 and SSC JE CBT2, then make use of calculator. There is no problem in that. Which is a wrong statement here. See, entropy is a function of quantity of the heat, which shows the possibility of conversion of that heat into work. It is somewhat, entropy is nothing but the amount of heat, and that heat which is not getting converted into work but can be converted into work. This is right, correct. Increase in the entropy is small when the heat is added at low temperature. This is a false statement. Why this is a false statement? Why this is a false statement? If you see entropy change, if you write in terms of heat by temperature, okay, so what is heat by temperature, my dear? Heat by temperature, if let's say heat is equal to 500 kilojoules. Now there are two temperatures. One temperature is T1 is equal to let's say 200, and one is T2 is equal to 300 Kelvin. Tell me, if the same heat is added at T1 temperature and other is at T2, which will be having more entropy? Find the entropy. 500 by 200 will be more, or 500 by 300 will be more. Which will be giving you more entropy? Obviously, this will be having more entropy. So this statement, that an increase in the entropy is small when heat is added low temperature. This is wrong statement, false statement. Now, this statement is false, wrong. Why this statement is correct? Why this statement is correct? Because what does entropy represent? Entropy represents that somewhat related to unavailable energy. Somewhat entropy is related to unavailable energy or irreversibility. And unavailable energy is nothing but the portion of the total energy which is also called as heat. which you are not able to convert into work. So actually it is representing that. For maximum entropy, there is minimum availability for conversion to work. If entropy becomes maximum, availability or exergy will become minimum. That is correct. When a system is at zero absolute temperature, entropy will be zero. That is correct. All the points are correct. Option B is incorrect. False. This is assertion reason type question. Assertion A is change in the heat and work cannot be expressed as difference between the end state. Change between heat and work cannot be expressed. For example, you cannot find, if you have to put work as, you cannot put work like this. Can you write work like this first of all? dW is equal to W2 minus W1. No, you cannot write like this. Neither you can write heat change is equal to Q2 minus Q1. Can you write like this? No, because they are path function, and path function does not depends on the point, they depends on the path. Okay, so this is correct. Heat and work both are exact differential. This is wrong. Okay, this is wrong. This statement is not correct. So A is true but R is false. Reason is false. Heat and work are inexact differential. They are inexact, not exact. They are path and they are inexact differential. Consider the following statement. First law of thermodynamics states that energy is conserved. First law of thermodynamics says that energy is conserved. Second law of thermodynamics states that though energy is conserved, its quality will improve. Second law of thermodynamics states that though energy is conserved, its quality degrades. First law tells about the feasibility. The feasibility is not discussed in the first law. First law says that energy is conserved. This is correct. One is correct. One is correct for sure. So these two cannot be right answer, not the right answer. Either A 1 and 2 or C 1 and 3 will be the answer. Second law of thermodynamics states that though energy is conserved but quality improves. No, it does not say quality improve, but it says though energy is conserved, quality degrades. Quality will degrade. Okay, so option 1 and 3 will be the answer. 1 and 3 are correct. Quality of the energy degrades. Quality degrades means heat. Heat is a energy and its quality degrades. How the degradation takes place. Although it is unorganized form of energy, you can convert that into work. Okay, you can convert that into work, but you cannot entirely convert it into work. Okay, there is some loss of energy. Okay, there is some loss of energy. Loss of energy, and that loss of energy is basically nothing but degradation of the energy. Okay, loss of energy is nothing but it is called degradation, because you cannot entirely convert it into work. This degradation is related to irreversibility. Okay, so this is explained in the second law of thermodynamics, that although energy is conserved, this is the total energy. Total energy is conserved, but its quality will degrade. If its quality will not degrade if you convert this heat into work completely, but you cannot convert this. There will be some loss of energy, that is called degradation of energy, which is the degradation of energy. Consider the following statement about Electrolux refrigerator. In an Electrolux refrigerator, ammonia is absorbed in water. In this, hydrogen is evaporated in ammonia. It is also called two-fluid system. First of all, it is not a two-fluid system, it is a three-fluid system, where the three fluids are used: ammonia, water, and hydrogen gas. So third statement, wherever there is third statement is wrong. In Electrolux refrigerator, ammonia is absorbed in water. Yes, correct, this is correct. In this, hydrogen is evaporated. No, hydrogen is not evaporated. You cannot do evaporation of hydrogen. But yes, hydrogen creates low vapor pressure for ammonia. It creates low vapor pressure. It helps in this. Hydrogen is not evaporated, it helps in evaporation. hydrogen gas helps in quick evaporation of ammonia. Quick evaporation of ammonia. That is important. There is some problem here, but what we have to do, there is only one option left, which is 1 and 2. You cannot, no, you don't have any other option, because third option is wrong, right? Straight away. Comparing the vapor compression system with vapor absorption system, the compression of the former means vapor compression system is the former system. Compression of the former is replaced with, so in vapor compression system we use a compressor, but in vapor absorption we don't use a compressor. Instead of compressor we use how many components? We use absorber, generator, pump and a pressure reducing valve. So these 4 components are basically the replacement of compressor. You can call it as a replacement of compressor in vapor absorption system. So in vapor absorption system we don't use compressor. Instead compressor we use these 4 components. All right. So you can see that, you can check that also, that a pressure reducing valve, these 3 components are common in vapor absorption and vapor compression, that is evaporator, expansion valve and condenser. But what other components are used? Generator is used here, pump is used, pressure reducing valve and absorber. These are the 4 components which are replacement of compressor in vapor absorption system. Okay. A sample of air is having 25 degrees Celsius of dry bulb temperature and relative humidity of 35% at barometric pressure of 760 and saturation pressure of vapor is 0.028. Vapor pressure will be. So relative humidity is given to you in this question. Relative humidity is given, which is 35%. Barometric pressure is given to you 760 mm of mercury. How to approach this question, solve this question, tell me. The vapor pressure you have to determine. See, this data is not used here. It will not be required. Relative humidity, which is phi, is equal to PV by PVS. In this question, they have given relative humidity. PV, they are being, it is asked vapor pressure. Vapor pressure is PV. And this saturation vapor pressure is given 0.028. So just you have to find this. Multiply, you will get the answer. Understood? The saturation, the barometric pressure is not required. You don't have to use barometric pressure. So if you multiply it, you will get 0.0098 bar. Okay, vapor pressure. Now, what is the advantage of using this? If you know this value of vapor pressure, PV, and you know this, you can find a specific humidity now, 0.622 of PV over P minus PV. You can find this value of specific humidity. That can be the use of finding vapor pressure. Data of a steam impulse turbine is as follows. Power developed per stage is equal to 60 kilowatt. Velocity of the steam from the nozzle is 400. Diagram efficiency आपको बताना है. What is diagram efficiency? Diagram efficiency also called as blade efficiency, or it is also called as utilization factor. So in order to determine this value of diagram efficiency, blade efficiency, utilization factor, formula is the power developed divided by the kinetic energy per second. So power developed is 60 kilowatt already given, right? So diagram efficiency will be equal to power developed, which is 60, divided by half of mass flow rate is not given into velocity square, that is 400 square. Solve it, you will get 60 into 2 into 1000 divided by, if you convert that into watt, you will get 400 into 400. Solve it, you will get the answer. Tell me what is the value you are getting for this. Why I have multiplied with 1000? Because if you find the kinetic energy, that will be in watt, not kilowatt. So that is why we have convert this into watt. So that will be 75%. Okay, if we solve it. Clear? This is the formula for diagram efficiency. Remember this diagram efficiency known as blade efficiency, known as utilization factor. It is the power developed at turbine rotor to the kinetic energy per second. Kinetic energy per second is half mv square. Although velocity is mass is not given, so you can take it as mass flow rate, you can take it as 1. If not given, you can take it as 1. Okay, I have just taken it as 1. This is half mv square, but mass is not given. Direct velocity square, and this is in kilowatt. To convert into watt, we have multiplied with 1000. Specific isentropic work of compression in vapor compression system decreases with. In vapor compression system, which of the following factor will decrease the work of compression? Compression work will reduce by decreasing the evaporator temperature at constant condenser temperature, or by increasing the evaporator temperature at constant condenser temperature. So if you see this option number B, if you see the work, this is evaporator temperature and this is condenser temperature. And from where you find the work? From here you find the work of compression. So if you increase the evaporator temperature is here and condenser temperature is constant, then the same work of compression will reduce. So the right answer is option B for this question. Okay. Is it clear? So if you really want to decrease the work of compression, if you want to have a decrease in work of compression, so this will be the decrease. If you increase the evaporator temperature, okay, and condenser temperature is kept constant, then compression work which was earlier this much compression work, now it will be reduced. Okay. 3 Rankine cycles are coupled in series. Efficiency of these turbines are 45%, 40 and 25%. Equivalent efficiency you have to determine. If there are 3 cycles in series and you have to find the equivalent efficiency, combined efficiency, then combined efficiency formula is, it is 1 minus efficiency of the first cycle into 1 minus efficiency of second into 1 minus efficiency of third. Just put all the efficiencies which are given: 1 minus 0.45, 1 minus 0.40, 1 minus 0.25. Solve it, you will get 1 minus 0.55 into 0.6 into 0.75. You will get the answer. What value you are getting? Tell me. Solve it, everyone. Tell me the answer. So if you solve it, you will get somewhat around 75%, close to 75. All right. Although 76, you will get 76, but 76 is not the right answer. Just a second. It will be 75. Why are you getting 65? Why are you getting 65%? This is 1 minus 0.45, then 1 minus 0.40, 1 minus 0.25. You will get 75 something, not 65. Please use your calculator. Okay. Next, SI engine has compression ratio of 10 and total volume of the cylinder is 0.80 meter cube. Find the mean effective pressure if the work of output is 1440 kilojoule. You have to find the work out mean effective pressure. The mean effective pressure is net work output to the sept volume. In this question, the net work output is already given to you. We have to get the sept volume value. How to find the sept volume? Where compression ratio is given, total volume of the cylinder is given. Compression ratio is equal to V1 by V2. What is V1? You can also call it as total volume of the cylinder divided by V2. What is V2? It is clearance volume. So from here you can get the value of clearance volume. Total volume is 0.80 and compression ratio is 10, so that will be 0.08, okay, meter cube. But if you have to find the sept volume, then you know that formula. Total volume is sum of sept volume plus clearance volume. From here you can get the sept volume value. Sept volume is total volume minus clearance volume. Okay. So there you get 0.8 minus 0.08. Somewhat around 0.72. It will be 1440 by 0.72. Solve it, get the answer. Yes, please everyone use calculator to solve the question. Don't make a mistake. Okay, so this will be you will be getting 2000 kilopascal, which is 20 bar. All right. So with this, should we end the session? This is, let's call off the session for today, and rest of the question will be discussed in the next session. Before I wind up this session, I want to tell you about that at Resultant we are having 3 types of courses for RRB JE. One is only focused for CBT 1 preparation, one is for CBT 2, which is called AIM batch, and one is for combined CBT 1 and CBT 2 preparation called Mission batch. These are the MRP prices and discounted prices. But if you really want to contact how to basically purchase these courses, you can call on this number or you can just mail us here. And we have a scholarship test which is going to be conducted. Scholarship test on 7th and 8th September. That is this Saturday and Sunday. If you perform well in the scholarship test, you can get good discount on these courses. Okay, just you can subscribe our channel and press the bell icon. Also, do not forget to like and share the session if you enjoyed the session. I am going to see you tomorrow with some more good questions like this. Okay, see you in tomorrow's session. Have a very nice day. Kal milte hain. Thank you so much. See you tomorrow. Thank you so much, everyone. Good night.